Hello friends, welcome back to the CSC Guy. This is our first lecture of our second chapter in computer networks. So let us start with data link layer design issues. Data link layer design issues. First of all, data link layer. It is a critical component of the OSI model, responsible for providing error-free transfer of data frames between two devices on the same network. The design of the data link layer involves addressing several key issues to ensure reliable and efficient data transfer. Services to the network layer. The data link layer provides services to the network layer, including framing, error control, and flow control. The main function of the data link layer is to provide a well-defined service interface to the network layer above it. Framing. Framing is the process of dividing the data into manageable units called frames. A frame consists of a header, payload, and trailer. The header contains control information, the payload contains the actual data, and the trailer contains error checking data. Error control. Error control is a critical function of the data link layer, ensuring that data is transmitted error-free. Error control involves detecting and correcting errors that occur during transmission. There are two types of error control: error detection and error correction. Error detection. This involves detecting errors using techniques such as checksums or cyclic redundancy checks. Error correction. This involves correcting errors using techniques such as retransmission or forward error correction. Flow control. Flow control is another important function of the data link layer, ensuring that the sender does not overwhelm the receiver with data. Flow control involves regulating the amount of data that can be sent at a given time. Medium access control. Medium access control is a sub-layer of the data link layer that manages access to the network medium. Medium access control protocols such as CSMA-CD, that is carrier sense multiple access with collision detection, and CSMA or CA, carrier sense multiple access with collision avoidance, are used to prevent collisions and ensure efficient data transfer. Scalability. Scalability is an important design issue in the data link layer. As networks are constantly growing in size and complexity, scalable data link layer designs can handle increasing traffic volumes and more devices without compromising performance. Interoperability. Interoperability is another key design issue in the data link layer, ensuring that different devices and systems can work together seamlessly. Interoperability is achieved through standardization and compliance with protocols developed by organizations such as IEEE and IETF. Emerging technologies. Emerging technologies such as 5G and IoT are driving the need for more advanced error control, flow control, and MAC protocols. These technologies require networks to support higher data rates, lower latency, and a large number of connected devices, pushing the boundaries of current data link layer designs and prompting innovation. In conclusion, the data link layer design involves addressing several key issues, including services to the network layer, framing, error control, flow control, medium access control, scalability, interoperability, and emerging technologies. By understanding these design issues, network engineers can build robust, efficient, and future-proof networks. Next, let us see different framing techniques in data link layer. Framing techniques in data link layer. First of all, framing. Framing is a critical function of the data link layer. It involves dividing the data into manageable units called frames. A frame consists of a header, payload, and trailer. The header contains control information, the payload contains the actual data, and the trailer contains error checking data. There are several framing techniques used in the data link layer, each with its own advantages and disadvantages. Carrier oriented framing. In carrier-oriented framing, a special character known as flag is used to indicate the start and end of a frame. The flag is usually a unique character that does not appear in the data. This technique is simple to implement but has some limitations, such as flag character limitation. The flag character cannot be used in the data, which can be a limitation in certain applications. Error detection. Error detection is limited as a single error can cause the receiver to lose synchronization. Another framing technique is bit-oriented framing. In bit-oriented framing, a special bit pattern known as a flag is used to indicate the start and end of a frame. This technique is more efficient than character-oriented framing as it can handle binary data. However, it also has some limitations such as flag pattern limitation. The flag pattern cannot be used in the data, which can be a limitation in certain applications. Error detection. Error detection is limited as a single error can cause the receiver to lose synchronization. Frame delimiting. Frame delimiting involves using a special character or bit pattern to indicate the start and end of a frame. This technique is similar to character oriented and bit oriented framing, but it uses a more sophisticated approach to detect errors. Next is length oriented framing. In length oriented framing, the length of the frame is specified in the header. This technique is more efficient than character oriented and bit oriented framing as it allows for variable length frames. However, it also has some limitations such as length field limitation. The length field must be large enough to accommodate the maximum frame size. Error detection. Error detection is limited as a single error can cause the receiver to lose synchronization. Next is fixed length framing. In fixed length framing, all frames have a fixed length. This technique is used to implement and provide good error detection, but it has some limitations such as inefficient use of bandwidth. Fixed length framing can result in inefficient use of bandwidth as frames may not be fully utilized. Limited flexibility. Fixed length framing does not allow for variable length frames, which can be a limitation in certain applications. Next is variable length framing. In variable length framing, frames can have different lengths. This technique is more efficient than fixed length framing as it allows for better utilization of bandwidth. However, it also has some limitations such as complexity. Variable length framing is more complex to implement than fixed length framing. Error detection. Error detection is more challenging in variable length framing as the receiver must be able to detect the end of a frame. In conclusion, each framing technique has its own advantage and disadvantages. The choice of framing technique depends on the specific requirement of the application such as error detection, bandwidth utilization and complexity. Next, let us discuss about flow control issues. Flow control design issue. It is a critical design issue in the data link layer, ensuring that the sender does not overwhelm the receiver with data. Flow control involves regulating the amount of data that can be sent at a given time, preventing network congestion and ensuring efficient data transfer. Why flow control is necessary? Without flow control, a fast sender can overwhelm a slow receiver, causing data loss, congestion, and network instability. Flow control ensures that the sender and receiver are synchronized, preventing data overflow and ensuring that the receiver can process the data efficiently. Types of flow control. There are mainly two types of flow control: stop and wait flow control and sliding window flow control. In stop and wait flow control, the sender sends a frame and waits for an acknowledgement from the receiver before sending the next frame. If the receiver does not receive the frame correctly, it sends a negative acknowledgement and the sender retransmits the frame. Advantages is it is simply to implement and it ensures error-free data transfer. Disadvantages is it is inefficient. It uses bandwidth inefficiently and slow data transfer rates. Next is sliding window flow control. In sliding window flow control, the sender sends multiple frames before waiting for an acknowledgement. The receiver sends an acknowledgement for a group of frames and sender slides the window forward, sending new frames. Advantages are more efficient use of bandwidth, faster data transfer rates. But what are the disadvantages? More complex to implement and it requires more buffer space. Next, let us see some error control techniques. Error control techniques are used to detect and correct errors that occur during data transmission. There are two types of error control techniques: error detection and error correction. Error detection. It involves detecting errors using techniques such as checksum and cyclic redundancy check (CRC). A checksum is a numerical value calculated from the data and appended to the frame. The receiver calculates the checksum and compares it with the received checksum. If the two values do not match, an error has occurred. Next, CRC. A CRC is a more sophisticated error detection technique that uses a polynomial equation to calculate a checksum. Error detection. Error correction. It involves correcting errors using techniques such as retransmission and forward error correction. Retransmission. The sender retransmits the frame that was received in error. Forward error correction. The sender adds redundant data to the frame, allowing the receiver to correct errors without retransmission. Error control protocols. Error control protocols are used to implement error control techniques. Some common error control protocols include automatic repeat request (ARQ). It is a protocol that uses error detection and retransmission to correct errors. Hybrid ARQ. Hybrid ARQ is a protocol that combines error detection and correction techniques. In conclusion, flow control is a critical error control techniques such as error detection and correction are used to ensure error-free data transfer. By understanding it, network engineers can design efficient and reliable networks. Next, see this question. A bit stream, that is 101101, is transmitted using the standard CRC method described in the text. The generator's polynomial is x plus 1. Now we have to show the actual bit string transmitted. Suppose the thread bit from the left is inverted during transmission. Now let us show that this error is detected at receiver's end. CRC error detection. To detect errors using the standard CRC method, we need to calculate the checksum and append it to the original bit stream. The generator polynomial is given as x plus 1, which is equivalent to 1 in binary. Now let us calculate the checksum. First, let's calculate the checksum for the original bit stream 1001101. With the generator polynomial, we will get reminder as 011001. The remainder is 0110. Since the generator polynomial is of degree 1, we need to append 1 bit to the remainder to get the checksum. Therefore, the checksum is 011. Now, next step is to append the checksum to the original bit stream. When we append it, 10011011011 is the transmitted bit stream. After that, we simulate the error during transmission. During transmission, the third bit from the left is inverted, resulting in the following bit stream. 10011101011 is the transmitted bit stream, and 1011110111 is the received bit stream with error. Now let us detect the error at the receiver's end. To detect the error, we need to calculate the checksum for the received bit stream using the generator polynomial. After we do it, the remainder will be 1001101. The remainder is not 0, indicating that an error has occurred during transmission. Therefore, the receiver can detect the errors. Next, let us discuss some important points. First, let us discuss the concept of redundancy in error detection and correction. Redundancy in error detection and correction involves adding extra information to the original data to enable error detection and correction, which can be achieved through forward error correction or retransmission. Next, let us distinguish between forward error correction and error correction by transmission. Forward error correction involves adding redundant information to the original data by enabling error detection and correction without retransmission, whereas error correction by retransmission involves resending the original data when an error is detected. Next, let us define linear block code and what is cyclic block code. A linear block code is a type of error correcting code where the code words are formed by linear combination of the information bits, and the code can be described by a generator matrix. A cyclic code is a type of linear block code where the code words are cyclic shifts of each other, and the code can be described by a generator polynomial. Next, let us see what is Hamming distance and what is the minimum Hamming distance. The Hamming distance is the number of positions at which two code words differ. The minimum Hamming distance is the smallest Hamming distance between any two distinct code words in a code, and it determines the error detecting and error correcting capabilities of the code. Next, let us see how the simple parity check is related to the two-dimensional parity check. How are they related? A simple parity check involves adding a single parity bit to a block of data to detect single bit errors. A two-dimensional parity check involves adding both row and column parity bits to a block of data to detect and correct single bit errors. Next, see this question. In CRC, let us show the relationship between the following entities. The size of data word and the size of the code word. Next, the size of divisor and the remainder. Next, the degree of the polynomial generator and the size of the divisor. The degree of the polynomial generator and the size of the remainder. We have to show the relationship between these entities. So, the relationships will be the size of the data word is smaller than the size of the code word. Next, the size of the divisor is equal to the size of the remainder plus the degree of the polynomial generator. Next, the degree of the polynomial generator is equal to the size of the divisor minus the size of the remainder. Size of divisor minus size of remainder, which is equal to degree of polynomial generator. Next, let us see what kind of arithmetic is used to add data items in checksum calculation. The arithmetic used to add data items in checksum calculation is modulo 2 arithmetic, that is binary arithmetic. Next, what kind of error is undetectable by the checksum? An error that is undetectable by the checksum is an error that changes the data in such a way that the checksum remains the same. Next, let us list 3 categories of multiple access protocols. 3 categories of multiple access protocols are random access, scheduled access, and polling. Thank you.